We go in, and first of all, we're going to see the white dwarf companion, a third of the mass of the sun. We're now going to see the pulsar spinning 100 times a second, although that was a little slower. And here we see an artist's conception of the planet. It probably doesn't have water. That blue is not due to water. And if we go back up a little bit, let's say from a moon, if such a thing existed, we do not know whether that's true. Thank you. What I'd like to describe for you today is a characterization of the oldest known planet. This planet is about 2.5 times the mass of Jupiter. It's located in a 13 billion-year-old globular star cluster. All the stars in this cluster are about the same age, so the presumption is that the planet is that old also. It's in an orbit which is about the orbit similar to the orbit of Uranus around our sun. That is, it's about more than 20 times the distance that the Earth is from our sun, and it takes almost 100 years for this planet to orbit around its central component. As you can see in the constellation Scorpius, the bright object is not the globular cluster, that's the star Antares, but as we zoom in, you can see the core of the globular cluster, and it gets beautifully resolved into stars by the Hubble image, which you can now see. As we go deeper into the core, you can see the phenomenal resolution of Hubble, and right near the center of that is the location of the companion to the pulsar.
But in this case, we have a star where we presumably could have formed not only a gas giant planet, but perhaps also a habitable planet 13 billion years ago, where life could have arisen and died out long ago, well before we came along to the galactic party. So it has immense astrobiological implications.